right, so our last example in section 5.3 is going to show an application of our multiplication rule. So according to a 2012 MetLife survey, 44% of U.S. public school teachers reported that they were satisfied with their jobs. Suppose we select 3 teachers randomly. It should be and with replacement from the population of all teachers in the United States. Selecting with replacement means that once a teacher is selected, they are eligible to be selected again. This means that probabilities do not change based on the first event, so the selections are independent. So if we see with replacement, that means that we are dealing with independent events, which means we can use our multiplication rule. So what is the probability that all 3 are satisfied? Okay. So we're going to take our probabilities and multiply them together. 0.44 times 0.44 times 0.44 gives us 0.0852, or 8.52%. All right, the probability that none are satisfied. All right, so none are satisfied means that each teacher selected is not satisfied. So if we think all the way back to our beginning when we started talking about a theoretical probability, we talked about finding complements. And we said that we found complements by taking 1 minus our probability. Right, so if we do 1 minus 0.044, right, that's going to be the probability that the first teacher is not satisfied. And then we're going to repeat that same thing for the other. So we're using our idea of complement here. So basically we're taking 0.56 times 0.56 times 0.56, and that is giving us 0.1756, or 17.56%. Right. Then last but not least, what is the probability that at least 1 is satisfied? So again, we're using our idea of complement. At least 1 is the opposite of none. So we're going to take 1 minus our probability of none, which was our answer to our last problem. And this is going to give us 0.8244, or 82.44%. So again, a nice example of an application problem. Because of the word with replacement, we had independent events, and since we had independent events, we could use our multiplication rule. Right? So we could multiply all of these different probabilities together, and then we also came back to where we started at the beginning of the section, kind of came full circle and talked about our complement as well and how that can be used in these problems, in addition to just our multiplication rule.